So I think that was really what sparked the curiosity.
You're going to have to fast forward, Will.
No. So that's like, so I've got 20 minutes left. Don't worry. It's fine. We'll get through it.
Hi, welcome to AI Confidential. I'm Aaron Fulkerson, the CEO of Opaque. This is the podcast where I sit down with industry experts to talk about the promise and potential of AI to create breakout industry leaders or to disrupt current leaders. After all, whoever controls the data controls the industry. For this episode, I sat down with Will Grannis, VP and Chief Technology Officer of Google Cloud. We discussed everything from why AI is more Baconator than Terminator, to the main obstacle preventing AI from moving from pilot to production. And we covered some really fascinating use cases Will is seeing in his role that hint at the remarkable innovations unlocked by AI in the future. I hope you enjoy this conversation. If you do, please subscribe to AI Confidential wherever you get your podcasts, and be sure to subscribe to our newsletter. Thank you for listening. Hi, Will. Thanks so much for joining us today. It's a real honor to have you here.
Hi, Aaron. It's great to be here.
So, Will, let's just start off with, tell me a little bit about your journey to Google Cloud. You have a really interesting background, and I'd love for you to share that with our listeners.
Sure. The long and winding road. This is the part where I go really slowly and everybody stops listening to the podcast. Sorry, Aaron. Sorry about that.
I doubt that. It's a fun story. You've got such an interesting background.
Well, it starts in the Shire. No, it actually started my grandma's house, and it was this little Pong system she had set up with the TV, and I was a little tyke, and I just thought it was fascinating how you could twist this little knob on this thing and watch this little bar go across the screen and knock this ball over. And I was like, man, that is so cool. And then, things got a little bit better, and I had I bought this Intellivision at a garage sale. You remember Intellivision? It was this controller that had a little disc on the bottom. It had a keypad. And I was like, there's no way. How does this work? So you can spin this little disc, and then all of a sudden Tron, or somebody would move on the screen. And I just thought that was the coolest thing in the world. So I think that was really what sparked the curiosity.
You're going to have to fast forward, Will.
No. So that's so I've got 20 minutes left. Don't worry. It's fine. We'll get through it. But, I think everybody has this moment where they find something that really gets them curious. And that was it for me. And so, fast forward a few years, math became really interesting to me as kind of the universal language between, human world and technology world. And then, gateway computers, you can modify PCs, you could put networking cards in, jack up the storage. It was awesome. And so that got, that was probably took me up through my first job. And my first job was in the military. And I got to tell you, in the military, there at the time, so this was early 2000s, I don't think there was a greater chasm between people needing things that worked and not having things that worked. And I think that was really what set me off in more of a technology direction as a career. I was always curious about it, but I saw how people who were standing up and ready to, put themselves on the line for all of us had just the worst technology, especially in IT. So I went to a small company, started building stuff, went to some bigger companies, started building things at scale, and then I was CTO of a public company. And one day, my head of data science, Amanda, for this task we were working on, we were trying to analyze what was called the GDELT database. It was all the activities, media activities, and events happening every day, and trying to do sentiment analysis on it. And it turns out to do that, Amanda told me it was going to take $4 million in a year. And I was like, ooh. That's obviously not in the cards. And then she went and found this capability called BigQuery. And at the time, BigQuery was a web UI user interface where you just drag tables over, and Google would host this website, and you could just drag tables of data over and analyze them for free almost instantly. And I saw that technology. I'm like, man, I got to get there. So I called a couple of friends at Google. I'm like, what are you doing over here in the Willy Wonka's chocolate factory of technology? I saw the Oompa Loompas. I want to see who else is in the factory? And got a shared corner of a cubicle farm with my laptop. I was an individual contributor. And, that was about 10 years ago. No job description, just show up. We were building cloud. It was called Google for Work. We didn't call it cloud like Google Cloud. It was pre-brand. And the whole goal was just to connect this amazing factory of technology to enterprises, because Google was pretty good at consumer tech. You've probably heard of Gmail, you've probably heard of YouTube, you've probably heard of Chrome, you've probably heard of search. Those have done okay. But from an enterprise perspective, we were just getting started.
So you got in before it was even Google Cloud or GCP. Talk about that journey to where your role has evolved today. What are your responsibilities? Where do you spend most of your time?
Yeah. So with my background's mostly in applied technology, in a variety of industries and scenarios. And so I came at it more from a non-consumer tech person and really someone outside of Silicon Valley, more of like representing the customers we wanted to have as cloud. And so my sensibilities were always, how do we take this amazing technology and actually make it useful for customers? So an example, BigQuery, which brought me to Google, it was a consumption-only business model. So you would think, oh, that's pretty cool. I can get on-demand analysis of scaled data, just by the minute or by the query. But if you're an enterprise customer, that freaks you out. And why does it freak you out? Because now you might have an unlimited OpEx bill that you hadn't planned, especially if it's a popular technology. So one of the first things we did is we actually changed BigQuery so that it would function and can be sold like an appliance. It wasn't an appliance, but we kind of packaged it like an appliance. So customers could buy slots of BigQuery the way that they would buy analytical appliances at the time. And it's those little kind of business and technical kind of rounding off the edges of what we were working on, but making them suitable for enterprises. That really parlayed itself into the role I eventually got as CTO, because after connecting enough of our technologies with our customers, I guess someone thought it would be a good idea to let me try to do that more proactively. And that's what I've been doing for the last 9 years, is building, I guess you could call us like the nerdiest Avengers. So like these individuals that all have a certain background. Some people have chip design, some are in quantum, some are in security, some are in like high performance computing, storage, networking, a lot in AI, everything from algorithm development to deployment on custom silicon. And over time we've assembled, if you will, this group of individuals, and we've turned them into a collective. And this collective does two things. One, it still helps our customers, largely, probably 250 or so customers today. We help them adopt this very complex technology for the first time. This is in banking, healthcare, media, retail, all public sector, all the industries do these first ofs and succeed. The second thing we do is then, you can imagine working with all of these customers over this long period of time, having access to all this technology. People are like, what do you think is going to happen? And we start to get these tremors of the future from our customers, things that might be really interesting. So for example, natural language interfaces to documents was something we were working on in 2016 because our customers had a lot of documents, but it was really hard to it was hard to interact with them in in an analysis pipeline. Today, now, fast forward, 7 years later, 8 years later, we have managed services called Document AI. And document synthesis is a primary use case in generative AI. But we saw these tremors of the future by working with customers, and then we applied some effort to try to catalyze Google's prioritization mechanism for our roadmap.
So you're working with 250-ish of the largest, most innovative, most strategic customers who are really pushing the boundaries of Google technology. And then you're helping them to solve really gnarly problems. And as a result of that, that informs the product roadmap, the product packaging, so that everybody in the GCP ecosystem gets to benefit from the great work you're doing on the bleeding edge with these strategic customers that are driving the innovation boundaries.
Yeah, you got it. Because I've been around a long time now. I've been an entrepreneur a few times. I've been in big companies doing, research and development, first ofs, and deployments at scale. And I can tell you it takes a long time, a lot longer than most people realize, to go from like a foundational new, concept to deployment. I mean, look at Transformers came out in 2017. It's now 2024, and we're just starting to see production use cases of generative AI that leverage the Transformers architecture and approach, making their way at scale in large enterprises. And this is a consistent theme. That's why you need, all large organizations, even mid-sized organizations, it doesn't have to be a large function, but they need some small group or people that are looking at what it's going to take to succeed and what are the really complicated bits around their technology, because the adoption curves aren't instantaneous, right? Even the fastest adoption curves that we're seeing now around generative AI, the seeds were planted on those, years ago.
Yeah. Speaking of AI, you've been speaking publicly from your perspective of optimism about AI versus others who are very pessimistic. You gave a great talk at the Collision conference that people I encourage to look up. Just search for Will and Collision.
Oh, thanks.
But given the rapid innovation that we're seeing, adoption aside, like you're talking about, a lot of people are pretty nervous about it, but you're very optimistic. Could you speak about that a little bit more?
Sure. The way I think about AI is it feels like an iceberg. Everyone sees the layers above the water and they're like, oh, this ought to be really easy to navigate. We got this. Look at how straightforward this is. And it turns out that underneath the water are all the subtleties that make AI work at scale. So I'm optimistic about AI because I know, and I've been putting AI into practice, deterministic and probabilistic for, probably close to 2 decades. And so I know that it works, but I'm also realistic about what it takes to make it work. And that's all the stuff under the surface that people generally don't see until they've really gotten, kind of elbow deep into AI implementation. And I'll give you an example. So right now, one of the hottest use cases in AI, in generative AI, is customer service. Somebody comes into your customer call center, is expressing pain, and typically we'd have humans help them navigate these issues. And it turns out that these issues are largely, from many, many people can boil down to a very similar set of issues, but it's really hard to know what those are because, they're all in these really long transcripts and you need humans reviewing them. It's very laborious. But there was a breakthrough that we were working on in the telco industry in 2017. And that was, we figured out a way to take millions of these intents that these customers expressed every single day and boil them down into like the 10 things that really people needed immediate help with or really wanted to get from these customer service centers. And it turns out that the algorithms that you use to do the clustering and the AI systems that you use to process this are totally transferable to other industries because customer service is like a horizontal industry. So you could take the same type of architecture and you could apply it in finance. You could apply it in healthcare. And it eventually turned into a product line that we call Contact Center AI. That's been one of our most successful AI solutions. And it's also, now it's gone to fast food restaurants. The same type of thinking and the same type of architecture goes into creating what we worked on with Wendy's called a menu parser. So they have all of this information. They have intents coming in from the customers in the line. And how do you match, these intents to like the core knowledge of an organization? And, that's how we got people Frosties and fries, a lot faster. And what it turns out, Wendy's was like the vanguard of generative AI and natural language interactions. For like the entire world. It was one of the leading use cases in 2023. But that's the under the surface stuff. That's the stuff so I'm optimistic because I've seen AI work, but I'm realistic about the timelines that it takes and the iceberg that people have to deal with in order to get the value from it.
So the Wendy's example is a great one because it's this application of AI that has sweeping ramifications across many industries. Explain that a little bit more. So as people are coming through the drive-through, you're parsing the audio and then making predictions about what to order?
So it turns out that all the technology to get like 75% of this problem solved already existed. So there are speech to text capabilities already in Android, Chrome, smart displays. There are already messaging systems with the ability to take that, text and then move it through a processing engine. The issue is that people don't use a strict semantic, interface when they're talking to a machine. They're like, I want Frosties, I want a fry. Well, is it a large fry? Is it a medium fry? And how do you get a system that's smart enough to know that matches to a set of options and then send those options back fast enough? And so kind of a little bit of the magic. There's two places of magic in that processing pipeline. One is coming up with this menu parser. So you can take the tens of hundreds of billions of combinations that someone could utter, that was related to a menu at Wendy's, not counting, by the way, that some people ask for like Big Macs and, they ask for the other restaurants' items in the drive-thru. So you got to solve for that too. But through having this menu parser and having a natural language interface that can understand the relationships between things that aren't strictly and hierarchically, developed ahead of time, those two pieces of magic, so generative AI and a menu parser put together, we were able to get to a level of accuracy and a level of speed that now these things are being deployed live at restaurants in the Midwest and performing extremely well. And that's just one example of a larger trend in AI, which is going to be, I think, really important. And that's grounding these AI systems in truth and in knowledge. That if you're an enterprise, what are the crown jewels? Is like your customers, your knowledge of your industry, your intellectual property. All of that knowledge, all of those processes, those are very specific to you and your competitive advantage. So you want to be able to ground these AI systems, especially generative AI systems. You want to be able to ground them in enterprise truth. And so what we learned from working with companies like Wendy's is that every company wants the ability to ground with sources of data that are highly factual and with their own data. And so a lot of what we've built out in Vertex AI is the ability to ground. You can use Google search now to ground these generative AI systems. So the web's knowledge is now available to ground these systems as they process. Companies can use their own enterprise data now to ground in these processing pipelines. We're even now able to use Google Maps and geodata, so entirely new forms of data, and grounding these systems in locations and kind of, locality and context there. So, it's amazing how, when I referred to the iceberg earlier, that, this is the set of things that sits underneath the surface that everybody sees like a fancy chat interaction or a cool, thing at a menu board at Wendy's, but underneath the hood, you've got this kind of steady progression of innovation, first in, clustering intents, then in developing enterprise truth systems that then connect to generative AI, and now expanding the set and the types of data that can be used for grounding. It just keeps going and going and going.
So one of the things you said was, what's most valuable to a company is their customers, the knowledge of their process, and their intellectual property. All of that is data. And data is the most valuable asset. I mean, other than the humans, right? The human resources, the people who work at the companies, of course, incredibly valuable. You don't have a business without that. Setting that aside, so people don't think I'm Machiavellian, it's really data that's the most valuable asset. And companies must control their data in the event that they leak any one of those data sets, their customer data set, knowledge of their processes, intellectual property, maybe it's Baconator recipes, I guess. It opens them to being disrupted by competitors, distribution partners, supply chain partners. We see this frequently with opaque customers, that the number one reason why AI products get stuck in pilot is related to ensuring traceability, sovereignty of the data that's being used in that AI product. So what are you seeing? We know that there's been a bottleneck in AI products moving from pilot to production. What are the common reasons that you see in the field preventing companies from launching and getting value from AI?
Probably first and foremost is trust. And I think this is a superset of a lot of the things that you were describing, data provenance, data security, just even how to reason about how these systems operate. And this is a big reason why we launched the Secure AI framework recently. And this is a conceptual framework for secure AI systems. It was really inspired by security best practices at Google, and it's applied to software development. So kind of, before these systems show up and are ready for production, how are we embedding, secure, trustable processes, checks, testing, all the way from the beginning, all the way to the end. And, we really think that it's a framework like this that's essential to making sure that, the safeguards are in place, that an organization, there's security, but then there's also trust, like brand safety. Some organizations want to be a little edgier. Some organizations want to be a little bit more conservative. And so one of the things we also did in addition to this framework is we started building these capabilities into software. So like in Vertex AI, our generative AI platform now, customers have the ability to select kind of degrees of filtering of outputs based on how creative or how definitive they want the outputs to be. And it turns out that there are a lot of experiences. You could think of these as like marketing, for example, customer experiences where for some reason people like a very exciting or unpredictable experience sometimes, right? Feels more human rather than, this, then that, then this, then that, which feels very computer sciencey. There are some times when you don't want creative outputs. So like account balances or, safety critical systems like air traffic management. You really want to get those right. You really don't want it to be too creative. And so, it's not just about these frameworks, which are critical, but it's also about embedding it in software. Because if there's, another theme, I guess, over my career, in addition to like the icebergs, right? The stuff underneath the waterline is the stuff that ends up mattering a whole lot, is also that principles are great, but for a tech company like us, we have to put it into software. And that's why we've spent so much time taking like these AI principles for safety and avoiding like toxic content. And we've embedded them into platforms so that customers now get leverage from that. They don't have to go and try to reinvent how to think about, moderating content. We can take some, best practices that we've learned over many years. We can apply them as a baseline, and then they can enhance, they can modify, they can dial it up, they can dial it down. But it's really important that they have those knobs because that's what builds the trust ultimately. You can have frameworks, you can have technology, but human beings and leaders and organizations want control. They want the knobs. They want to be able to dial it up and dial it down in the way that they see fit for their brand. They should be able to do that. And that's exactly why we've built, Vertex AI, our platform, to have a range of options that they can customize and tailor.
What you said about trust really resonates with me. There's a poverty of trust in society today. And it's actually why I joined Opaque. I was really intrigued by Opaque's ability to provide traceability around data. And it took me a bit to figure out why that was so important to me. It was really about trust. People's trust with big tech in particular is eroded dramatically, our political systems, our governmental systems. And it all goes down to a lack of trust. And the best, there's certain things you can do to increase trust, like consistency, reliability, a demonstration of altruism. But really fundamentally, what everybody wants when it comes to their AI workloads is control. It's really about having transparency and control of the data that engenders trust, that allows companies to move forward with AI and other technology innovation. And I just wanted to put a spotlight on that because I think it's really an important point you make about trust is probably the single largest, and don't let me mischaracterize what you said, so feel free to push back. But what I heard was trust is really the single largest reason why companies flame out in their pilot moving AI workloads into production. And what can help companies solve that is control.
Yeah. And, it's an interesting point you make because I think it even goes beyond data. At some point, you have enough invested in these AI systems. And think about this. You're going to put an AI-enabled product in front of your B2B clients, in front of your, millions, if not billions of users or consumers. The stakes are really, really high for those moments. So in addition to kind of the data, think about all the upstream things of brand safety, the way that the design works. Does it represent, the way that you as a brand want to show up? And especially as we get into multimodal generative AI, where you can create images, you can create videos. Now you're generating content that's going to be embedded in one of these experiences or showed to all of those customers. And so now it's new data that hadn't existed before. So, that's why we did things like synth ID, like watermarking generated content so people could trust generated content, because that's a whole new, problem space created by this era of generative AI. But ultimately, we see our responsibility as making sure that all of those surfaces have the appropriate levels of control, and that our customers are the ones who control the way that those knobs and dials are turned and spun, because ultimately they're the ones who are responsible for their own brand safety, for the experiences with their clients, and that's the way they want it. This actually spins into another topic, Aaron, which is, I think, how we arrived, at least my observation of how Google has arrived at this conclusion in particular around trust. And that is because we've had this moment, this reckoning of not being able to trust anything. In the late 2000s, we had this incident at Google that really shaped the future of how we view security. Now, today we call it zero trust security, but back then we didn't realize that compromised credentials could, bring down an entire service and erode trust in, this very, very popular in Gmail, which is the hack at the time. And, that zero trust security foundation, it's not just about tech. It's really about questioning every technology, process, and risk framework that you use through more of like an earned privilege model versus an inherent privilege model. And that mentality, concurrently with AI, zero trust security has also been on the rise within organizations. And I think that these two things are converging. So this earned privilege model is like, well, how does the AI enabled content, how does the AI enabled service earn the right to be deployed? Through monitoring, tests, feedback loops. And so a lot of the things that, we've used in other forms for zero trust security are now being applied to AI as well. So that convergence, I think, is also an important, not just conceptual convergence, but actual like software engineering and process convergence that's happening within a lot of our leading customers.
So this is a great point you bring up. And it makes me wonder, although you're overall optimistic about AI, what are some of the things that scare you about AI? Like, you're talking about being able to watermark and having an earned trust model. And I have some ideas about what you're scratching at there that would be potential really impactful, dangerous attack vectors. But what are the things that really scare you about AI?
Well, first, I want to say I'm very optimistic about technology in general, because I know how bad humans are at forecasting the positive impact of new things, because we don't have the mental models to reason about them, and so we learn them in real time. So eventually,
this is like printing presses and linen. The faster horse, always been
faster horse versus car, right? The classic example. And so, at least in my experience, this optimism comes from knowing that we're probably undervaluing the leaps forward that we're going to make, and it also comes from a very pragmatic place of understanding how humans are. Like, I have been in just about every scenario I can imagine. I've been in a one-person company, my own, bootstrapped with, a laptop, a shared office, rented space, and a dream, all the way up to like the CTO of a public company, of many, many billions of dollars in revenue, and everywhere in between. I've been in the public sector. I've been in the private sector. I've been in high tech. I've been in low tech, no tech, like out in the middle of a desert with a laser designator that was designed in 1959 that, only is attached to a vehicle that was, built in 1959. And, having seen technology adoption and, kind of been in all these scenarios, I'm just very pragmatic about what it takes to actually design these systems and implement these systems. As you have to come from a place of, like, AI isn't a product. It enables entirely new products, platforms, and experiences. And maybe even it supercharges existing technology. And it creates scaled leverage when applied correctly and carefully. But it's in all of those kind of implementation details. So, for example, some of our earlier customers were like, hey, we've got data and we want to combine it with the model and we want to do that at runtime, but we want to do it securely. We want to keep them separate. We're like, great. We know how to do this because a cloud pattern called service controls on top of virtual private clouds allows you to kind of carve off these projects and carve off this data and carve up this compute and allow these things to interact at runtime and then go back to the secure container that they were existing in. We totally know how to do that because it's a cloud pattern. So if you think about, AI as an enabler, the product itself that was sitting on top of that, this analysis that they wanted to do, it wasn't AI, but AI was being used to enable the product. And because we thought about it that way, we also thought, well, you can just use cloud, generally adopted cloud patterns to keep data, to keep compute, to keep roles, to keep identities segregated in the way that needs to be segregated for that to run from a regulatory standpoint. And that was for financial services, which is a very high bar for regulatory purposes. So that's why I think, try to be very pragmatic that we can apply these patterns of cloud. We can apply these patterns of least privilege. We can apply these patterns of segregation and combining only when appropriate. We'll get into trusted execution environments. We'll get better at, confidential compute on GPUs, on, other forms of custom processors. All of these things will come, and they're the same patterns, the same methodical engineering that we've been going through for the last 20 years and moving from owned data centers to cloud.
Yeah, this is helpful to think about. What you said about AI is not a product is so obvious and yet so commonly forgotten that it's not a product, it's a technology. If you think about the anti-patterns.
Yeah, I mean, think about this. It's also not a chat. It's also not a chatbot.
Yeah.
It's not a single model. It's not a chatbot. I think what we have is we have a range of scenarios. Scenario one is if you're a company and your intellectual property and your value proposition is on the best model, then you have an inherent incentive to try to make, like one model and one experience seem like it can solve all the problems. If you are more of a platform organization, your goal is to make sure that you provide as many models with the type of functionality that fit a range of use cases. And you want to focus on the reliability, the instrumentation, the security, the data provenance, the bits that go into composing technology on top of these models. And that's my perspective and what I see with our customers every single day. These are, global 200, 250 plus, the hottest startups. There's a reason why over 90% of these startups are choosing, these generative AI startups are choosing us for the underlying infrastructure and platform, is because it helps them, create that first scenario, like differentiate quickly on their model or on their singular service. But it's also why we have such a large investment and we're seeing such great adoption on Vertex AI, which is our AI platform, because most customers, if not all of them, at some point, for reasons of procurement diversity, risk management, highest performing model, they will have a range of models that they will test against their new experience. Some big, some small, some multimodal, some singular, some domain specific, some task specific. And so platform engineering and platform is very different than, singular model optimization. And, I definitely see what I experience with our customers is much more demand on the second, to the point where we're even, looking at technology and kind of looking ahead a little bit, how we can optimize that experience for our customers. How does a customer express an intent? I want to send a query and I want that query to execute most efficiently with the highest performance. Here are the constraints. Give me the best that you've got. Like Snap, for example, this My AI that they built with us. Snap tested all of our models. They tested everybody's models. And they chose us for this experience after very rigorous testing. If there's another framework I can share with listeners that at least, we use and I find very helpful when dealing with AI, especially generative AI, is rapid experimentation robust evaluation, and constant refinement. And that type of a framework is how our Google Cloud's customers are adopting AI, the most successful ones. And that implies multiple models, platform, machine learning ops, so managing the life cycle of these models over time, constantly optimizing, and a culture of experimentation. And that's probably, from a non-technical standpoint, it's probably the biggest enabler that I see, is a culture that allows for, this kind of rapid experimentation, this constant and robust evaluation, and then constant refinement, because that's a very different way of doing innovation for many enterprises, especially large ones, especially in industries that are maybe not as far tech forward. They're used to procure bunch of machines, write the solid business plan, do the CapEx, buy all the machines. A year and a half later, you've got your project. It either succeeds or it fails, and I'm going to fire everybody if it fails, or they get to do it again if it succeeds.
Your framework you've outlined here, rapid experimentation, robust evaluation, constant refinement, is how all successful companies execute building products or just servicing their customer. And doing that ensures that you're defining a future for your business. If you're not doing that and you're instead relying on a vendor to dictate to you what AI is, and you're using their AI to check a box on, we have AI, you're allowing some other person to define the future of your business.
That's why I say also, Aaron, find some friends, find some compute, and get moving. Because the barriers to entry now are so low for actually getting access to the world's most advanced computation. Like if you were to click into the cloud, you could go to cloud.google.com right now. You could go to the console, you could go to Vertex AI, and you could have access to over 150 models that are managed for you. We'll deploy them, we'll set them up, you can experiment with them, you can throw them in a sandbox, you can tear it all down without having to do any code. That is a very, very different world than even 3 or 4 years ago, where you had to be a data scientist, you had to have a notebook, Colab or Jupyter Notebook. You had to kind of be code aware, because those notebooks are not like, in English, they're in code, Python, usually. But now, without any of that knowledge, you can go and you can experiment. You can combine them in the safe cloud ways that we talked about before and try some of these experiments. You can blow it all away because cloud is ephemeral compute. And you can go, and if you're just an individual developer and you're like, I don't even want to do that. I just want to throw something in a sandbox and play around with it so I can learn new skills. You can go to Google's AI Studio. You can try any one of these models that we have, these advanced multimodal models. You can put them in sandbox. And if you find something that works, you can get an API key and you can take it right to an enterprise grade platform. So like the barrier to entry to get started, to be curious, to play around, to experiment, to learn is so low.
Every major technology super cycle through human history occurs when a particular product excites the imagination of the society, and that coincides with that technology becoming more accessible than it ever has been. So it was Netscape with the internet. And that kicked off this massive super cycle. It was the iPhone with mobile. Now we saw, granted, it was ChatGPT was the one that sparked everybody's imagination about what was possible at a time coinciding with the accessibility of these technologies being unprecedented. So if you look forward into the future, I don't care how far into the future you want to pick. Things are happening so fast. 3 years seems like a long time from now. What are you excited about being unlocked through the potential of AI?
Well, in addition to just the complete transformation of almost every industry you can imagine, transportation, commerce, the public sector, I'm personally really excited about scientific discovery and those use cases. So, for example, new synthetic crystals or minerals that could reduce our reliance on, the earth and it providing all of these raw materials. Our ability to characterize the universe around us. We did a project with the B612 Foundation, the Asteroid Institute, where we were able to categorize almost 30,000 new asteroids, including some very interesting ones very near the orbit of the Earth. We were able to do that on old archive data using basic data analytics and do it in a few months. And now we have these other, observation telescopes coming online. I can't even imagine what we are going to be able to characterize and discover and the pace at which that'll happen. I mean, like my youngest daughter wants to be an astrochemist because of exposure that she got to these, platforms and these advances. It's inspiring an entire new next generation of scientists, astrophysicists, chemists, new treatment options based on new molecules and new drug discovery, and the whole AlphaFold series of discoveries happening at DeepMind. Maybe even most importantly, access to personalized education. We know that there's probably a 2 standard deviation, positive change for people that have personalized education access. The problem is it's really expensive. Personalized education access means tutors. Some people can afford them. Most people can't. And that's creating a chasm in education. But with AI, now every student has the potential to have personalized educational assistance. And if you really want to get wild, the world around us. So, you may have some birds flying around, near in your backyard. You got the animal kingdom out there. Well, we're working with an organization that is decoding the speech of the natural world. So there are actually signals that occur between a bee and a flower when it goes to land and it chooses which flower to land on. And using AI, we're actually starting to uncover the secret language in the natural world hidden all around us every single day.
That's fantastic. Examples of really exciting areas that AI is going to be disruptive and really accelerate human innovation. Thank you for sharing, Will. And I couldn't agree more that every industry is going to be disrupted. Not probably, in my mind, undoubtedly more than any other technology super cycle. This is the one that's going to be the most disruptive. And I, like you, am very optimistic about this. I believe that it's going to be disrupted for the better. And, you said this earlier, we as a species have survived. I'm using my own words. We've survived by being inherently pessimistic. We're constantly building mental models for attack vectors of animals that are going to kill us or technologies that might kill us, like linen looms. Like the Luddites destroyed.
The lizard brain run wild.
So it's natural for us to do that. We're really good at coming up with all these possible combinations that might kill us. But you said it well, that we're very poor at modeling a future state where what are the positive impacts? Like, who knew that like the mountains of horse manure that were through the streets of the cities were going to go away? Like, that was a huge problem that people couldn't even conceive being solved overnight. And it literally was solved within the span of not overnight, but it was very quickly. Thank you so much for your time today, Will. Really appreciated chatting with you. It was super fun.
Aaron, really my pleasure. Thanks for having me.
Thanks for tuning in. We hope you'll join us next time for another exciting interview. If you like the show and want to learn more about these topics, check out our website at opaque.co. If you like the podcast, please subscribe and leave us a review wherever you get your podcasts. We really want to hear from you. And I hope you enjoyed this episode as much as I did, hanging out and chatting with Will. We were cracking each other up throughout the whole episode. I almost wish there was an outtake section. This episode of AI Confidential was produced by Opaque, the leading confidential AI platform. I'm Aaron Fulkerson, and I hope to see you again.